morning, class. Welcome to math class. Today we're going to talk about how clocks work. So first thing we're going to do is talk about definitions that we've already talked about. Scott, can you read the first definition of analog clock, please?
Analog clock. Clock which shows time with two moving hands which move in circular motion, and the clock face is marked from 1 to 12.
Can you point to an example in the classroom of an analog clock? Good job. Isabel, can you read the definition to digital clock?
A clock or watch that shows the time using the numbers, not hands.
And can you point to one in the house? There's one in a certain direction. You're not supposed to have your phone in class. It's also on the stove. All right, the next definition, I'll read it. It's minute hand. The long hand on a clock or watch that indicates minutes that have passed in that hour. And so that's just the long hand on. And what kind of clock would that be, Scott? An analog or digital clock?
Analog.
Good job. Isabel, can you read hour hand?
A small hand on a clock that points to the hours. It goes once around the clock every 12 hours.
And so which one is that, the long or the short hand?
It's short.
Is that analog or a digital clock?
Analog.
Good job. Scott, can you read hour?
Hour. One of the 24 equal parts of a day. 1 hour equals 60 minutes.
Good job. And Isabel, minute?
A unit of time equal to 60 seconds.
And we kind of discussed both of those in our previous lessons about time and you guys telling time. So a new one that we're going to kind of talk about later in the lesson is steady. And steady is a regular, even, and continuous in development, frequency, or intensity. And you'll understand that as the lesson goes on. So to start off our lesson, I'm going to have you guys do a quick assessment from digital to analog. You're going to just draw the hands to this times here. All right, good job on that worksheet, guys. All right, next we're going to have a worksheet, but before I pass it out, I have a slide with the questions that we're going to have. In the space below, list the kinds of timekeeping methods you know about already. And then the second question is, in the space below, list all the things you can think of that are needed in a good timekeeping device. So I must put you guys up in groups. Okay, you two are in a group. All right. So now discuss as a group number 1 and number 2. If you have questions, raise your hand, and I'll be circulating around the class.
We learned about analog clocks.
And digital clocks.
All the things you can think of that are needed in a good timekeeping device. Consistency.
A representation of the hour and minute.
You both have to write stuff down.
Yeah, Scott.
That's right to you.
You know another clock? A sundial.
Oh, you can put that up there. That's a good idea. Have you ever heard of a sundial, Scott?
Yes.
Is that how you learned how to tell time?
Must have been rough when you were younger.
And
Not having
images.
clocks.
Especially if the dinosaurs were blocking the sun. Go ahead.
I think we're done.
Are you done?
Yeah, there's a part 2, but
Okay, don't do part 2 yet. Okay, so today's activity involves figuring out what can be used to make clocks, or make a clock to keep time. So we talked about that. we're going to watch a video involving time and clocks and a rescue attempt. All right. The Cyber Squad enters a pyramid in Egypt to search for Dr. Marbles and the encryptor chip. They come to a passageway with a large stone door. It is slowly lowered into as water drips out of 2 tall cylinders on either side of the door. They need to know how much time they have to find Dr. Marbles and get it back out. So they invent a clock. There are essential elements in accurate measurement of time, or what are the essential elements in accurate measurement of time? Take notes and write down the essential elements as you watch the video. So if you think of more while you're doing that, and number 2 would be a good idea. Okay, we just watched the first clip, an Egyptian clock. What are the elements of timekeeping that are represented in the video segment that you heard in there?
Second? Is that what you're asking?
Did they say seconds really?
1 alligator, 2 alligator.
Yeah, they were talking about seconds like that. That's right. They were talking the word steady. I remember that was one of our vocabulary words. They were talking about steady rate, steady pace, steady counting. And they were talking about how when she sneezed, it wasn't steady because it threw off her counting. But you can't count while you're sneezing, okay? And then the hourglass was kind of one. All right, we're going to watch another video. In the next video segment, there are lots of different types of clocks. Use part 2 on the handout right here to write down many types of clocks that you see in the video. All right, so we just watched the video, a world tour of clocks. What were some of the different clocks that you guys had on your lists? Scott?
Sundial.
Isabel?
Hourglass.
Did I talk about hourglass in there? Oh, I guess he did have it on his wrist. Yeah, go ahead. And what about you?
Pulsometer.
Yeah. Isabel?
Watches.
What kind of watches?
Analog and digital.
Mm-hmm. What else?
Grandfather clock.
Mm-hmm.
Grandmother clock.
Oh, very interesting.
That's all I got.
I think he had a broken watch, a wrist watch, human clock, and pendulum clocks. All right.
A broken clock doesn't meet our definition.
You're correct, but that's what he did have on there. All right, so we're going to do an activity now, and you guys are going to stay in your groups. You can pass in your papers there. Good job. All right, so this one is a word problem one. And I'll read the top of it for you. It says, Jamie constructed a funnel and sand clock, which measures time by the number of cups of sand poured from the funnel shown below. If it takes 20 minutes to fill each cup, number 1, figure out how time has passed using the time below. So work together as a group to figure out that first block there.
Well, there's 3 cups. Well, 4 cups, and 3 of them equal an hour. But the this one right here isn't filled up all the way, so it's at least 1 hour.
Scott, what do you think that last cup might be?
Well, it says a half a cup. So a half of 20 minutes is 10 minutes.
Oh, good job. Do you agree, Isabel?
Yes.
All right, good job. All right, so then the second box says, draw the number of cups that will be filled with the sand in 2.5 hours. Make sure you're discussing with your partner too.
I'm drawing 7 cups, 6 that are full, and 1 that
what answer did you guys come up with?
7 1/2.
All right, good job. All right. Sometimes a person doesn't have a watch when they try to keep track of time by saying something like 1 Mississippi, 2 Mississippi, 3 Mississippi. And on the movie that they were saying 1 alligator, 2 alligator, 3 alligator. How does that help a person keep track of time, Isabel?
By counting it makes it keep track of per second, and per second is a minute.
How does Mississippi make it 1 second, though?
It takes 1 second to say it.
Yep. And what do they have to do when they are doing this to make sure it's fairly accurate?
Say it at the same rate.
Yep. Steady? Yep. All right. How does the grandfather clock work, Isabel?
You said it had a pendulum in it to keep track of it.
Is a pendulum important, Scott?
Yes,
Why?
because it sets the pace.
A steady pace? All right. Since a pendulum would be too large for a wristwatch, what acts as a replacement for a pendulum in a watch, Isabel?
It's like, I think it was like a circle thing, like a beat maker or something like that.
Do you remember?
The balance wheel.
Yes, good job. I had it right now because I forgot. What is the difference between an analog and a digital clock or watch, Isabel?
One uses arms and has a balance wheel in it, and one tells the time by a screen.
Which one's which?
The digital's with a screen,
Mm-hmm.
and the other's not.
All right. Good job, guys. Thank you for coming to math class.